Okay, in this video I want to talk about conditional probability with trees. So here is our formula. The probability of event E given that event F has occurred is equal to the probability of event E and F occurring over the probability of event F occurring. So since it's conditional probability, there's an event F that we know that has occurred. So we do not need to divide by the sample space. We want to divide by the event F that we know has occurred. Sometimes E and F cannot occur at the same time. So if that happens, then these would be of probability 0. And that does happen. We don't often look at examples where it's probability 0 because those aren't as interesting to us, but it does occur quite often. So that is a possibility with something like this. But in general, it's the probability of event E and F occurring at the same time divided by the probability of F occurring, since F would now be the new sample space since we're guaranteed that it has occurred. Okay, so definition. The probability of event E given that event F has occurred, which is denoted probability E given F. Okay, so let's look at an example. An example is each day there's a 30% chance probability that we will leave our umbrella at home. If we leave our umbrella at home, then the probability it will rain is 60%. So if we take our umbrella, it will rain with probability 10%. Okay, so this is a conditional probability because it's dependent on if it rains or not, judged by if we take our umbrella. So since this is a multi-step process, a multi-step probability problem, I would suggest doing a tree. And so that's what I've done down here. I've made a tree. So there's a 30% chance that we will not have our umbrella, 70% chance we'll have our umbrella. Okay, so if we have our umbrella, it's only a 10% chance that it will rain. If we do not have our umbrella, so I put umbrella complement, if we do not have our umbrella, it's a 60% chance that it will rain, okay? So given that we don't have our umbrella, it rains is 60%. So we can tell by the tree. Okay, so what are we trying to solve for? If we leave our umbrella at home, given that it rains, what's the probability? So what's the probability we leave our umbrella at home given that it rains? So we don't have our umbrella is down here, and it rained, so it's here. Okay, so if we multiply these two, then that is them together. So we can say, okay, well, it would be 30% chance that we don't bring our umbrella and 60% chance that it would rain. So it would be 30 times 60. So that's going to take us at 18% chance that this occurs. And this will be our numerator. This will be the top. So when we write this, we're going to write this on the top. Okay. So this will be the probability that they occur at the same time. We leave our umbrella at home, or we don't have our umbrella, and it rained, okay, over the probability that it rains. Okay, so we've already determined that this is 18% right there. Now, what is the probability that it rains? Okay, well, here's where the green stars come in, because it rains here and it also rains here. So I need to find this as well, and this would be 70% chance we bring our umbrella and 10% chance that it rains. And so 7 times 1 is just 7, so this would be 7%. Okay, so there's a 7% chance that both of these would occur at the same time. And so this would have to go in the sample space. There we go. There. So that should do it. That should be our final answer. The only thing that's left to do is to do the arithmetic. So we should be able to go 18% per 100 over 18 and 7 which would be 25%. So we have 18 over 25, and there we go. So that is what I believe the answer should be. So 18 over 25, well, that would be, I mean, if you want to plug it in your calculator, it would be roughly 72%. Okay. Or 18 out of 25. So I hope that helps of seeing it broken down into a tree. Yeah, let me know if you have any further questions.